As they say, mathematics is queen of sciences. It's a true statement. We need it for all science because mathematics tells you how to think logically, how to deduce results, what is the hypothesis, from what you can deduce what. So the logical thinking, the thinking, so that gets developed by mathematics. So that is the first thing you need to do any science. So, and in basic sciences, what you do typically is model the world around us. It can be physics, like modeling things around us, or even geometry, just the space around us. Biology also, you do the same thing. You try to understand things by modeling things, various phenomena. And when you model things, you use mathematics. There is no modeling without mathematics. You model the theory. So you build a theory, looking at the things. Once you build a theory, then you have to test it. Okay. Any physical sciences or biology, anywhere. Once you build the theory, you test it. So initially in modeling, you need mathematics. When you test, you do the experiments or you go to the field and observe things, and then you collect statistics. You get the data. So invariably there are errors and things like that to be taken into account. So then you need probability theory and statistics to analyze the data. You verify the things. So that comes later. So initial modeling, you need mathematics, like differential equations and such things. You need all the time. And then later on for analyzing things also you need. So this is for basic sciences. So all basic sciences you need mathematics. So then there is technology. So because you have mathematics now everywhere, you have so much of technology, phones, that all communication, you have technology, you are what they say, you are digital world, you digitize everything. So that means any data, any information you have, you convert it into numbers, okay, sequences of zeros and ones. It can be sound, it can be video, audio, video, or anything. You convert it into a number, basically just a number of sequence of zeros and ones. Then you convert it back. So all recording, everything is done digitized way. So you use a lot of mathematics there, like your mobile phone, in GPS, everywhere there is a lot of mathematics. You may not see it. You think that mathematical theorems are not useful, but that is not the case. You use it all the time in your technology. Right? So basic science is the one part to understand the world around us. Technology is where we make use of this science. That is again there you use mathematics. So like sometimes you develop mathematics just for sake of mathematics, just because you like it and you enjoy doing mathematics. You may develop mathematics without any application in mind. But very often we do that. But maybe some years later, people may find some use for it. So it might get applied. That has happened many a times.
Firstly, high school mathematics is syllabus is modeled so that it can help in other sciences usually. So in that sense, it's like a service course. High school.
In school, you learn numbers and addition, multiplication, or computations, and then algebraic manipulations. So with like a plus b square is a square, b square, like that. You learn the things, and maybe in geometry you get a glimpse of what is theorem proving and things like that. But when you come to higher mathematics, like in bachelors, undergraduates, masters, there you learn there is a lot of history of mathematics, several centuries of mathematics. So you learn the basic theorems, basic results proved in various centuries, and the various branches of mathematics, how they are related, like analysis, algebra, various modern things also like probability theory. You learn those things. Once you learn the basic results and theorems and you get an idea, so then later on when you come to PhD, then you can learn more of recent developments, recent results, and what is there to what things which we don't know and what things we should be proving, the recent problems and things like that. So then you can try to solve some of the problems. The mathematics is not about computations. Many people think that higher mathematics we will be doing a lot of computations. That is not the case. We learn more structures, algebraic structures, we say. So the relationship between them. And so these things take some time to understand what they are about. So that you don't study in school. So it is not there.
So the difference is that when you have to get into deeper questions, you end up building some abstract theories to explain these things better, to explain complicated proofs better. And so there's far more emphasis on conceptual arguments and theory, as opposed to just formulas that you would probably learn in engineering mathematics or what you learn in like school mathematics.
See, in the BMath course, we have people who are active researchers who are teaching this. So both the way of teaching and also way of judging, everything is based on problem solving. So now what happens is people are active researchers, they know how to apply something, so they pass it on. In the beginning, BMath students, even very good students, struggle to solve problems because it's some art to learn how to convert what you have learned into solving a problem. But that initial struggle is over, they cross a threshold, then they can always do problem solving very well. That is what matters. Now in a person who's pretty talented, she doesn't join BMath, she joins a BSc. It's possible she might top the class, get 100 out of 100, but most of the time she may not be able to solve a single problem unless you have some kind of practice of applying things that you have learned. So this, and one more thing in BMath course is that you have around you not only faculty who are active, there are also postdocs and research scholars, other peers. All of them have gained this experience of problem solving, seniors. So their whole atmosphere is different. You are doing problem solving. Through problem solving is how you can learn a subject better. Admission is advertised around beginning of February. It starts for a month. Online admissions take place, and then this happens. And there are also some special incentives, like people who are in Olympiad, going through the Olympiad process. They are in the top 30 in their country. They can write. They don't have to write the exam. They can go through the interview directly.
Once you have filled the application form, etc., then you have this entrance exam, which will be in May, I suppose, and then the entrance exam will have two parts to it. There's a objective type and there's a subjective type. So there are two papers, and you have to do well in both the papers. And after that, if you do well, you will be selected and called for an interview. And in the interview, we'll ask maybe a couple of questions. It will last for about 20 minutes. And once if you do well in the interview, also you should get an offer of admission from my side.
BMath, the main focus is on mathematics. Various subtopics in mathematics like algebra, analysis, and things like that. But then we also have some probability and statistics, then some computer science, some physics. Recently, we have also introduced some economics, so that students are not too specialized too soon. So they can learn other things. They can see how mathematics is applied in other areas, and they can choose better.
Now here, each of the things in BMath, whether it's an core courses like algebra courses, analysis courses, differential equations, optimization, or geometry, topology, all these courses are given individual attention. So there are a lot of time you spend on developing the basics. And after that, there are, of course, in a BMath course, you have a chance of doing elective courses in the final year, where once you learn the basics of topology, geometry, you can take differential geometry, algebraic geometry, things like that. Or somebody is inclined towards statistics or maybe actuarial sciences, they take, they go for probability courses, financial mathematics, and economics is also possible. So you have to, by the second year, you can decide whether you want to go more in a particular direction, and you can take electives accordingly. I don't think this kind of freedom or this kind of depth is there in a general BSc course.
It goes without saying, there is no tuition fee, and I think there is some nominal charges for the hostel. Because currently the stipend is 3,000 rupees per month, and there is some annual contingency for purchase of books. But the stipend may get reduced a little bit if the student is not doing well, badly. So in fact, it might get off completely if the student fails or has to repeat it in 1 year. On the other hand, if the student is doing very well, getting more than 80% or something, then some special prices are given annually every year. With that, they can buy books and other things.
Academically, I would say it's somewhat more informal, and we encourage students to participate actively in class. They can come anytime to our office and ask us questions. We encourage them to think about various many such questions. We have seminars and colloquiums going on regularly, and some of them are geared towards students, some of them may be more advanced, so they get exposure to what is higher level, research level seminars and colloquiums. There is library, and where they have access at least during the daytime.
Well, again, in BMath course, it is quite different from many colleges and many other places, because the exam structure is quite different. It depends on the teachers. And again, we expect students to think more, learn how to think, how to do things logically, how to solve problems by logical deductions, rather than just the usual just repeating things and memorizing things. That is not what encouraged. So the exam structure, I think, is quite different. So it takes some time for students initially to realize that. So, and also some students initially are quite taken back because they maybe used to get more than 90%, 95%, 99% like that. But when they come here, they see that they are not getting scores of that kind, but they are competing with others of same high level. And it doesn't really matter whether one really scores 90% or 8% like that. One should do well, one should understand the subject. That is what they are looking at. So if the students are studying regularly and keeping up, doing the assignments, they will have no difficulty in completing the course.
The first one that will come to my mind is, of course, a research career. So you become, if you are successful in research, you can become a faculty member, professor in some university. But if you can also branch out, also there is, since we teach a fair amount of statistics, that also helps you get into industry. You can branch out into economics, financial mathematics. That will also, maybe after additional, maybe a master's course, it will get you into industry. But even after BMath, you have a fair amount of chances to get into industry. So those are the other options.
Although the prospects are such that you can do many things, but typically what happens is that many of the BMath students, they are interested in going for masters and PhD. So in pure mathematics rather than. But there are quite a handful of people, even after doing BMath, they go for MStat. People have gone for London's financial mathematics, London School of Economics. So people do go to economics or probability areas, actuarial sciences. After statistics, they might sometimes go for a PhD, but often, if after a BMath, if you go for an MStat, usually they end up working in a bank or so they end up earning several times what their teachers earn here. So that way, prospects for people who do so-called applied mathematics, which means a lot of probability courses and economics and statistics. So they have lots of prospects.
The hostel facilities here are excellent. It's better than most places, and now the student strength is also quite good. So regularly they are able to play. There's a lot of activities going on ground play and also in cultural activities. The institute itself gives funds for cultural activities, and they can also have educational trips. The institute pays for that.
So I see lot of, there's a big playground, so I see people playing cricket, football, volleyball. So certainly sports, I think, is very much visible here. And I think now there's a film club also, so they are showing films regularly. So I can see that these activities are there. There is also, I think, art kind of cultural activities. So there is, I think, ample scope for people to develop their hobbies and these things apart from just academic.
No, different age groups are there. We have students from the Masters MS List program and other MSQMS, and we have our own MMath and we have research scholars. So some of the communities, because of different ages, it gels very well.
There is library, there is gym, and for sports activities there is equipment, and then, as I said, the institute funds for that, institute pays for that. So even cultural activities the institute pays, and medical facilities the institute gives.
Mathematics wise, earlier when ISI, the very old days, because ISI was the biggest name all over the world in statistics and probability. So people like C.R. Rao and Varadhan and so on came up. So those days, the mathematics areas which were developed were kind of sister areas like operator theory, function analysis, probability. So these are all sister areas of statistics. So it is like a supportive area. So we had big experts in them who were well renowned. So at the same time, because of the presence of such stalwarts, we also had other people doing some other areas in mathematics. We had Parsarthi, S Varadarajan, Rangarao, these kind of people who were doing Lie groups, representation theory things, which is not exactly related to this. Of course, they were also experts in these areas, but because they had made such a big name, some of them went to the US and they stayed there. So now, what has happened in the last few years, because at starting of this program, BMath and MMath, already BMath started in 2000. That's the reason I moved here actually. Then 15 years are over, and then the first few batches, people have already become well known. We can be proud about people like Ritabrata Munshi, Amalendu Krishna, Abhishek Saha, Sucharit Sarkar, Mahesh Kakde. These have already made a name for themselves. Yeah, some of them have chosen to stay abroad, and after BMath or something, instead they went to PhD, direct PhD in a big place, and then in fact Ritabrata is back in ISI. So I think it's areas wise now the strength of areas are much wider now. Whether it's algebraic geometry, number theory, typically in ISI used to be strong in analysis, operator theory, function analysis, which are very strong. Even now it's strong. Those areas are non-commutative geometry. But the new areas which are after all things like Fermat's last theorem which is solved. So this has led a lot of people to take up number theory and allied subjects, arithmetic geometry. There are quite a few people in the faculty, young people who are doing these areas, working on these areas. So the facet of ISI has changed that way. It has contributed a lot, I would say.
Well, in research, I think the only Abel Prize winner, the highest prize, I guess, in mathematics, the Abel Prize winner from India was SRS Varadhan, studied in ISI. got degree from ISI, and we have any number of researchers from ISI. You see in mathematics or statistics and probability theory. So if you visit any most US universities, if you see the Department of Statistics, you see one or two from ISI. And now even in India, if you go to ISERs, the new institutes which are coming up, and if you see the faculty profile, there are many who studied in ISI. The number of papers published in mathematics from India, see, I think after TFR, the ISI comes next. The centers of ISI, it is topping. So that is for research. So, but ISI is also quite active in teaching. So unlike many other allied institutions, ISI has been very actively engaged in teaching, in training students. We also regularly run workshops, instructional workshops for students and teachers from outside, from universities. So that is another aspect. Then ISI was involved in planning the 5-year plans, and even now we have regularly interactions with the government, and also we have the quality control unit which engages with various companies in regard to quality control and things like that. And if you go to Calcutta, there are many other fields ISI is engaged. Like the dinosaur, for example, ISI was very much involved in research and getting the dinosaur and doing geological studies. And there are many other fields ISI Calcutta is involved, including computer science. That is the contribution. So, right, research and as well as teaching, and some things about the nation building, some learning statistics. And so now the official statistics is done by the government separately, but often they ask ISI for help in various things. A professional mathematician, one should do a bachelor degree in mathematics, like the BMath honors, okay. And then the master's degree in mathematics, then PhD. Okay. So that's where you learn how you can try to prove some results of your own in PhD. And then the postdoc comes, the postdoctoral research, where, see, in PhD you typically do problems suggested by your supervisor, because you don't know what sort of problems one should be trying to solve and things like that. Then you get more freedom when you do postdoc. Okay, you can work on yourself individually, you try to prove some results independently. So that is for 2-3 years. Then one can join as a faculty somewhere, some research institute. That is the way it goes.
I think students who are fascinated by mathematics, who would like to spend a lot of time thinking about mathematics or mathematical puzzles kind of thing initially, but eventually they will have to commit to reading more and more mathematics theory. So people who are fascinated by mathematics should certainly consider a course here, because this will train them for a lot of advanced mathematics.
You should follow your dreams. You should be confident enough to follow your dreams. Of course, your parents should be supportive. So if you are good at something, do that. Now, if you are good at mathematics, it's presumably that true that you will be good at generally academics, and possibly you might have done very well, and people might be pushing you on to engineering or medicine. If you like it, you do it. But if you think you are particularly interested, come for mathematics. Come to a good place. As I said, don't waste yourself by going to BSc because you want to live in a particular place. Okay? Because what will happen is you will top the class. You will never develop beyond a certain level.
ISI is, I would say, is a friendly place for students. A lot of interesting mathematics is taught here. So rather than, I would say, for many people, rather than simply trying engineering, which is the predominant craze at this level in India, people should look for other things which cater to people's interests. So the student is really interested in mathematics, maybe this is one place they should consider, because this is one of the few places which teaches a lot of mathematics to students at this age.
Now, I'd like to add also BMath, how the students are doing after completing the Bachelor of Mathematics. See, we started BMath only in 2000. Okay, so it's not very old. And Bachelor of Statistics is quite old now. So it was started in 60s. But already you can see BMath students doing a mark. So you can see them in various universities. Many of them, just after the Bachelor program, have gone for a PhD. So you can see that they have gone to various places like Oxford, Princeton, Berkeley, and many places in Europe. So there are our students, they are doing very well, and some of them have come back and expect things will grow. I think the future for mathematics is quite good in India.